dark matter and dark energy are most of the energy and matter that's out there. Our interface just plain flat out hides them.
Hey guys, it's Sai. If you're super curious but don't always have the time to watch your favourite podcasts, you've found the right place. Here's your summary of Lex Fridman number 293, featuring Donald Hoffman, in less time than it takes to do your taxes. Donald Hoffman is a cognitive psychologist at UC Irvine, renowned for his theory that our perceptions are not reflections of reality, but survival-oriented interfaces. His work challenges conventional, scientific views on consciousness and perception, positioning him as a leading thinker in modern cognitive science and philosophy. Let's jump in. Donald Hoffman starts off by challenging the foundational idea that our perceptions reflect reality. He argues that evolution has shaped our sensory systems not to perceive truth, but to facilitate survival. One of his key statements is, the idea that what we see is reality is just wrong. He uses the metaphor of a computer desktop interface, where icons do not represent the actual complexity of the computer's hardware. Hoffman's theory suggests that what we perceive is merely a user interface for navigating the world, not a direct reflection of objective reality.
Many Nobel Prizes about particles and fields and all that kind of stuff that slowly builds up to something that's perceivable to us, both with our eyes, with our different senses, from DNA to embryos, to cells that make the human body.
Right.
So all of that is not real.
It's a real experience, and it's a real adaptive set of perceptions. So it's an adaptive set of perceptions, full stop. We want to think
the
that
perceptions are real.
So their perceptions are real as perceptions, right? They are. We are having our perceptions, but we've assumed that there's a pretty tight relationship between our perceptions and reality. If I look up and see the moon, then there is something that exists in space and time that matches what I perceive. And all I'm saying is that if you take evolution by natural selection seriously, then that is precluded. That our perceptions are there. They're there to guide adaptive behavior, full stop. They're not there to show you the truth. In fact, the way I think about it is they're there to hide the truth because the truth is too complicated.
He further explains with the example of how a snake in the grass might look like a stick to us, not because it is a stick, but because our brain interprets it in a way that's advantageous for survival. The implications of this theory extend to questioning how much of science, based on observation, might be an oversimplification or misrepresentation of true reality. Hoffman delves into the concept of spacetime, suggesting it's not fundamental, but a construct of our perception. He explains, spacetime is the stage upon which we act out our lives, but it's not the final word in physics. He discusses how physicists like Einstein have hinted at the idea that spacetime might be an emergent property, not a basic one. His theory posits that conscious agents create spacetime as a kind of data structure for interaction.
It's interesting to think that evolution might be a very crappy interface into something much deeper.
That's right. They're both telling us that the framework that you've had can only go so far, and it has to stop. And there's something beyond. And that framework, the very framework that is space and time itself. Now, of course, evolution by natural selection is not telling us about like Einstein's relativistic spacetime. So that was another question you asked a little bit earlier. It's telling us more about our perceptual space and time, which we have used as the basis for creating first a Newtonian space versus time as a mathematical extension of our perceptions. And then Einstein then took that and extended it even further. So the relationship between what evolution is telling us and what the physicists are telling us is that, in some sense, the Newton and Einstein space-time are formulated as sort of rigorous extensions of our perceptual space, making it mathematically rigorous and laying out the symmetries that they find there. So that's sort of the relationship between them. So it's the perceptual space-time that evolution is telling us is just a user interface, effectively. And then the physicists are finding that even the mathematical extension of that into the Einsteinian formulation has to be as well not the final story. There's something deeper.
He elaborates with the thought experiment of how different species might perceive the same physical event in different ways, suggesting that spacetime could be more about utility than truth. This leads to a profound discussion on the nature of physical laws and whether they might be more like rules in a game we've been taught to play. The conversation turns to reductionism, where Hoffman argues that reducing complex phenomena to their parts does not explain consciousness or reality fully. He quotes, "Reductionism is dead, as is spacetime." He critiques the idea that by understanding the components we understand the whole, using the example of how knowing all about neurons doesn't explain consciousness.
In fact, what got me into the field that at MIT was work by David Marr on this very topic. So David Marr was a professor at MIT, but he'd done his PhD in neuroscience, studying just the architectures of the brain. But he realized that his work, it was on the cerebellum. He realized that his work, as rigorous as it was, left him unsatisfied because he didn't know what the cerebellum was for.
Yeah.
And why it had that architecture. And so he went to MIT and he was in the AI lab there. And he said he had this 3-level approach that really grabbed my attention. So when I was an undergrad at UCLA, I read one of his papers in a class and said, "Who is this guy?" Because he said you have to have a computational theory. What is being computed and why? An algorithm. How is it being computed? What are the precise algorithms? And then the hardware. How does it get instantiated in the hardware? And so to really do neuroscience, he argued, we needed to have understanding at all those levels. And that really got me. I loved the neuroscience, but I realized this guy was saying, if you can't build it, you don't understand it effectively. And so that's why I went to MIT. And I had the pleasure of working with David until he died just a year and a half later.
He introduces the idea that emergent properties, like consciousness, cannot be deduced from their parts alone. Hoffman suggests that a new form of science might be needed to grasp the holistic nature of reality. This perspective challenges the traditional scientific method and calls for a paradigm shift in how we approach understanding the universe. Hoffman uses evolutionary game theory to explain why our perceptions might be misleading. He explains, evolution molds our perceptions to fit our needs for survival, not for truth. He describes scenarios where organisms evolve to see utility rather than truth, using examples like the perception of colour, which might not correspond to real light wavelengths.
So the best pushback we've gotten is from a team at Yale, and they suggested that if you use thousands of payoff functions, so in our simulations we just use a couple, one or two, because it was our first simulations, right? So that would be a limit. We had 1 or 2 payoff functions. We showed the result in those, at least for the genetic algorithms. And they said if you have 20,000 of them, then we can find these conditions in which truth-seeing organisms would be the ones that evolved and survived. And so we looked at their simulations, and it certainly is the case that you can find special cases in which truth can evolve. So when I say it's probability 0, it doesn't mean it can't happen. It can happen. In fact, it could happen infinitely often. It's just probability 0. So probability 0 things can happen infinitely.
He delves into the mathematics of how evolutionary dynamics favour survival-oriented perceptions. This leads to discussions on how deceptive, or illusory, perceptions could be more advantageous than accurate ones. He illustrates this with the concept of fitness payoffs, where seeing things in a certain way provides a survival benefit over seeing things as they truly are. Consciousness is central to Hoffman's argument, where he posits, consciousness is not derived from the physical world. He suggests that consciousness might be the ground from which physical reality arises, not the other way around. He discusses experiments that challenge the notion that consciousness is merely a byproduct of brain activity.
There's global workspace theory, and neuronal global workspace theory. So there's many theories of this type. What's common to all of them is they assume that space-time is fundamental. They assume that physical processes in space-time is fundamental. Panpsychism adds consciousness as an additional thing. It's almost dualist in that regard. And my attitude is our best science is telling us that space-time is not fundamental.
Hoffman introduces the idea of conscious agents as fundamental entities that interact to create what we perceive as reality. He uses the metaphor of a network where consciousness is the nodes and interactions are the connections. This view radically shifts the traditional materialistic perspective on consciousness. The podcast explores how we might visualize reality if it's not what we perceive. Hoffman suggests that our visual system is more about creating representations for action than showing reality. He says what we see is not a picture of reality, it's an interface to interact with it.
An ant, it's obviously living, but I'll say it appears to be living.
Yeah.
But when we get down to a virus, now people wonder, and when we get down to protons, people say it's not living. And my attitude is, look, I have a user interface. The interface is there to hide certain aspects of reality, and others to it's an uneven representation, put it that way. Certain things just get completely hidden. Dark matter and dark energy are most of the energy and matter that's out there. Our interface just plain flat out hides them.
Mm-hmm.
The only way we get some hint is because gravitational things are going wrong within our. So most things are outside of our interface. The distinction between living and non-living is not fundamental. It's an artifact of our interface.
They discuss how vision simplifies complex data into manageable forms like how we see colors or shapes. He uses examples from optical illusions to demonstrate how our brain constructs reality. This leads to a broader discussion on how art and science might converge in understanding perception. Hoffman and Fridman touch on the transient nature of life and existence through the lens of his theory. He states, life is an ephemeral dance of conscious agents. They discuss how our temporary perceptions shape our understanding of existence.
We fight over possessions because we think that we're small little objects inside this pre-existing space-time. We assume that mansion and that car exists independent of us, and that somehow these little things, can have our sense of self and importance enhanced by having that special car or that special house or that special person. When in fact, it's just the opposite. You create that mansion every time you look. You're something far deeper than that mansion. You're the entity which can create that mansion on the fly. And there's nothing to the mansion except what you create in this moment. So all of a sudden, when you take this point of view, it has all sorts of implications for how we interact with each other, how we treat each other.
This conversation explores the philosophical implications of living in an illusory world. They ponder on how this understanding might affect our daily interactions and our pursuit of truth. The ephemerality of life in this context becomes a beautiful, yet fleeting phenomenon. This conversation explores the philosophical implications of living in an illusory world. They ponder on how this understanding might affect our daily interactions and our pursuit of truth. The ephemerality of life in this context becomes a beautiful, yet fleeting phenomenon. Finally, they discuss what science might look like with Hoffman's theories in mind, where he says, science needs to evolve beyond the current paradigm. They talk about how science might need to treat consciousness as fundamental rather than emergent.
And if Gödel's incompleteness theorem holds here, and there's infinite variety of structures for consciousness to some sense explore, that maybe that's what it's about. This is something that Annika and I talked about a little bit, and she doesn't like this way of talking about it, and so I'm going to have to talk with her some more about this way of talking. But right now, I'll just put it this way, and I'll have to talk with her more and see if I can say it more clearly. But the way I'm talking about it now is that there's a sense in which there's being, and then there's experiences or forms that come out of being. That's one deep, deep mystery. And the question that you asked, what is it all about? Somehow it's related to that. Why doesn't it just stay without any forms? Why do we have experiences? Why not just have, when you close your eyes and you pay attention to what's behind you, there's nothing, but there's being. Why don't we just stop there? Why didn't we just stop there? Why did we create all tables and chairs and the sun and moon and people, all this really complicated stuff? Why?
They discuss how this could lead to breakthroughs in understanding the universe and ourselves. This conversation suggests a potential renaissance in scientific inquiry. It's an optimistic look at how science could evolve. In wrapping up Lex Fridman's podcast with Donald Hoffman, we've navigated through a complex tapestry of ideas about reality, perception, and consciousness. Hoffman's theories compel us to question what we think we know, pushing for a re-evaluation of science, philosophy, and our place in the universe. This episode doesn't just inform, it challenges us to think differently about everything from the physics of our world to the nature of our existence. Whether you're deeply involved in these fields or just intrigued by the big questions, this conversation is a profound journey into the mind's interaction with what we call reality. It's a call to keep questioning, exploring, and perhaps one day understanding the true nature of our universe. If you learned something new and want to spread some love, we would really appreciate it if you hit the bell icon to get a head start on new episodes uploaded every other day. Make sure to like and subscribe and comment below if you think aliens are real. If you want to stay updated, head on over to X and give us a follow at solutionsai_. All links are super easy to find down in the description and pinned to the top comment.